2 years ago, I had also a talk with a friend of mine, with Sophie, about that topic. And in the last 2 years, some things developed and so on. So I will just show you some new aspects of the whole thing. And I think it could be a very nice connection to the talk of Eric before, because it's also about a bit more about linked open data, and also about a different kind of techniques and ideas how to create sustainability. So yeah, I will talk today about linked open OHM and how to publish and interlink various OHM data. My name is ᚑᚌᚆᚐᚋ. I'm a research software engineer at the Department of Scientific IT at the RGZM in Mainz. And for this OHM project, I got a fellowship from the Open Science Fellows Program from Wikimedia Germany in 2020. So in the COVID phase, but I will just show you some results and some new things on that. And you will see a lot of pictures in this talk, because me and my dad, we had a trip some weeks ago in Ireland to visit the OHM stones in the field, and I will just show you some pictures and some technical aspects and semantic modeling behind that in this slides. So what's OHM? OHM is basically some kind of a script, early medieval script from the 4th to the 6th century AD of some kind of primitive Irish inspired from Latin somehow. And mostly distribution, it's distributed in Ireland, but also in Wales, England, and all in the Isle of Man. And mostly it's written on stones, but it also appears in other objects as well. But the stones are right now also in the field in Ireland everywhere. So this OHM inscriptions contains some of names and relations, and these inscriptions feature kindship or tribal relations, and could be markers of clan territories, cenotaphs, or just try to present some important people somehow in the field. Also, the archaeologists in Ireland really don't know what they are really about. And there are some formula words. The most popular are maki, which can be translated in English to son, or mukoi, which could be translated to tribe. So maybe X is the son of Y, or X belongs to tribe Y, or something like that. And there are also some nomenclature words and names. For instance, kuna, which could be translated to dog or hound, or katu, which could be translated to battle, or something like Luke or Ak, which could be some kind of god somehow. And this OHM inscriptions form a network in the end, so some kind of a graph. And that's the thing why we are in the domain of linked open data and linking things. So for instance, if we have the stone with the number CIAC 200, it's written on that some kind of maki whatever, maki mokoi whatever. So something, it could be that it's a son of Dal, son of Georges Fergus, son of the tribe of Toja, and so on. So you maybe have a lot of relationships between people, tribes, and so wherever on the stones. So our aim in the end is to have linked open data, and we want to provide and integrate OHM data in community hubs as linked open data, just to share it with others. And we think, and I think, linked open data is the future. Eric said something before about that. So just in short, linked open data is very simple. Just the linked open data principles just say that everything in the world just have an URI and an identifier, a unique identifier, which could be resolved in the internet. You can just get some data, and it's linked everywhere, and to build a huge knowledge graph, or the so-called linked open data cloud. But the question is, if you want to look at all OHM stones from Ireland, where can you find them? And there are a lot of publications, books like the CIIC by McAllister. There are some online databases like the ZIP database, database from the 1990s. There are some modern online and open databases like the 3D Ohm project, which already scans some Ohm stones and just published the 3D data and Epidoc XML files and so on. Also, the WebGIS from the heritage management in Ireland just shares something, but there's not really an official resource for linked Ohm. So yeah, our project started, and it started nearly in 2019, where some research squirrels, so some friend of mine and me, just started to do something with that kind of Ohm data. It was Sophie and Timo. In 2020, this project was, as said before, funded by the Wikimedia Germany Foundation, and the Open Science Fellows Program. And normally I wanted to visit in this studies Ireland and the Ohm stones, but yeah, there was the COVID time and so on. So yeah, everything moved 2 years, and a couple of weeks ago I have done this kind of trip to the Ohm stones with my father, with my dad Peter, and yeah, you will see the results and also the modeling results in the next couple of slides. In the next slides, I will just show you how the open data workflow works in some couple of steps. So, and the hybrid Ohm LD workflow is based on the idea of open science, open software, open data, and the FAIR principles to create reusability and a modular IT infrastructure with community standards and commonly used interfaces. So in the first step, the origin data will be digitized and transformed just into a CSV file to do everything else in some kind of a structured format. Then in step 2, the data modeling schemes, so in this case, ontologies and Wikidata mapping schemes, are created to transform the data into RDF or quick statements for Wikidata, using Python scripts to allow also some iterations and to do it automatically. In step 3, the resulting data is then ready to import into an RDF or JTriplet store and Wikidata. So the RDF data goes into a triplet store. Right now it's an RDF or JTriplet store, but it could be any triplet store. But yeah, there's only one Wikidata. And on the same side, the data is stored and also published together with the scripts on GitHub with a direct connection to Zenodo. So every version of the data and of the scripts get directly in the UI, and its metadata is described within CFF file. So I think hopefully everything is open and is citable. And so the resulting data is then ready to import into an RDF or JTriplet store. And Wikidata, that was the same thing. But you can then extract the data with some programs, research software to do some further analysis with open source software. And the big question is how to access this kind of data. So if the data is already in a triplet store, you can just access this kind of triplet store with a Sparkle endpoint. That's the cool thing about that. If the data is in Wikidata, you can just access the data by the Wikidata Sparkle query interface or several interfaces that Wikidata provides. Or you can use just a Sparkle endpoint in other research software. For instance, if there is an possibility just to integrate Sparkle endpoints into R if you want to do some statistics, like here some density maps or whatever statistics. Or you can use for QGIS the Sparkling Unicorn QGIS plugin, which is also work of the research school engineers of Timo Homburg and myself, just to integrate Sparkle endpoints and Sparkle queries in QGIS to do some geospatial things. And You can also use a reference viewer, which I wrote. It's just a small, lightweight JavaScript framework to find similar catalog numbers, or just a simple lookup tool to visualize find spots on a map somehow. So what are the next steps? We want to integrate OWN data into OpenStreetMap because they are missing. We want to integrate OWN data especially from the Dingle Peninsula, but that was the area where our trip was about. We want to update our linked open data that is already was created 2020 and the Wikidata items, and add more collections from museums and books. And yeah, we'll just show you some pictures on the next slides from the trip. There are some OWN stones in the wild, like this one. It's on Dunmore Head, so the most western point of Ireland, which now have also an item in OpenStreetMap in Wikidata, and it's also available at the before mentioned 3D project, OWN in 3D project with a 3D model. Same here with the famous OWN stone with a hole in it in front of a ruin of a church. One more, which is lying on a church. Also a ruin. It was not easy to find it, and it was also not mapped in OpenStreetMap. So now it's also available there. And then we have also two more stones as an example on a graveyard, which were also not mapped on OpenStreetMap before, but we have also some nice 3D views and data models to download at the OWN 3D website. Also this one, which is a bit hidden in the graveyard, as you can see. And there are a lot of OWN stones in museums, in local museums, or also in the in the university at the UCC in Cork, at the Stone Corridor. There are 28 stones which you can just see. Just without pay anything. That's a cool thing. And there are also two OWN stones in the Trinity College in the Book of Kells exhibition. So that's a cool thing, and they are also right now in OpenStreetMap. And if you have that data into OpenStreetMap, you have a lot of more APIs and web services to get in this data, like histosm.org or the Overpass Turbo API, whatever. A lot more possibilities. So what are the remaining challenges? One of them is something that Eric before also mentioned. So problems in IT sustainability and hosting of resources for, in this case, non-institutional funded project is even a bit more complicated than if it was funded, because this is a project just in a free time somehow. And but I think we have a lot of opportunities. So data can be maintained by archaeologists or citizen scientists on GitHub or on Wikidata. And Wikidata edits are connected by bidirectional links between OWN LLD and Wikidata. So just the big question at the end, how to solve that thing. So in our own case, we try to use the so-called squirrel power and the research squirrel engineers network to create a community of enthusiasts and looking forward. So if you want to join us and you're interested in these own things, just contact us. So that's it. And if you could just go to own.link, you can check out all the things and all the links. And the slides are also available on Zenodo. That's it. Thank you.
Thank you very much, Florian, for this insight and for the perfect timing as well.